Components of WAVs, sensors and payloads. The use of unmanned aerial vehicles, WAVs, has become increasingly popular over the years, especially in industries such as agriculture, construction, disaster management, and military operations. SA aircraft are equipped with sensors and payloads that make them capable of a wide range of tasks, from data collection and monitoring to surveillance and reconnaissance. In this article, we will discuss the components of WAVs, focusing on sensors and payloads and their important role in UAV operations. Sensors are devices that measure physical properties such as temperature, pressure, distance, and light, among others. WAVs are equipped with different sensors depending on their intended use. Some The most common sensors in WAVs include 1. Cameras. Cameras are perhaps the most basic and common sensors in WAVs. They are used to capture images or videos of a specific area or object from different angles. Cameras can be further classified into several types, including RGB cameras, thermal cameras, and hyperspectral cameras. RGB, red, green, blue, cameras capture images in the visible spectrum. Thermal cameras, on the other hand, capture the infrared radiation emitted by objects and translate it into temperature readings. Hyperspectral cameras capture images in several narrow bands across the electromagnetic spectrum, providing a more detailed view of the terrain or object being observed. 2. LiDAR. LiDAR, light detection and ranging, is a technology that uses lasers to measure distances and create a 3D representation of the terrain. LiDAR sensors are used in WAVs for mapping and surveying applications, as they can create accurate digital elevation models and maps of the terrain. LiDAR sensors are also used in urban areas for building modeling and infrastructure monitoring. 3. GPS. WAVs rely heavily on GPS, Global Positioning System, to navigate and precisely locate their position in the sky. GPS sensors are embedded in the WAV's navigation system and use signals from satellites to determine their exact location. GPS sensors are essential for tasks such as aerial surveying, mapping, and inspection. 4. Inertial Measurement Unit, IMU. An IMU is a device that measures the UAV's orientation, velocity, and acceleration. It consists of an accelerometer, gyroscope, and magnetometer fused together to provide a real-time estimation of the aircraft's motion. IMUs are commonly used in WAVs for flight control and stabilization. 5. Gas sensors. Gas sensors are used to detect harmful gases in the environment. WAVs equipped with gas sensors can be deployed to monitor the air quality in areas affected by natural disasters, wildfires, or industrial accidents. Gas sensors can also be used in agricultural applications to measure the concentration of gases emitted by crops, which can indicate their health conditions. Payloads, on the other hand, are devices or equipment that are carried by WAVs to perform specific tasks. Payloads are usually attached to the UAV's frame and vary greatly in size and weight depending on their intended use. Some of the common payloads used in WAVs include 1. Delivery payloads. Delivery payloads are designed to transport goods or packages from one location to another. They are commonly used in industries such as logistics, e-commerce, and healthcare. Delivery drones are equipped with a cargo hold that can accommodate packages weighing up to a few kilograms. 2. Inspection payloads. Inspection payloads are used for monitoring and inspecting infrastructure such as bridges, power lines, and pipelines. The payloads consist of sensors and cameras that can faults or damages in the infrastructure. Inspection drones are used to access hard-to-reach areas and provide greater visibility for inspectors. 3. Surveying payloads. Surveying payloads are used for aerial surveying and mapping applications. They include LiDAR sensors, cameras, and GPS receivers that are used to create accurate digital ELIVA. Tie-in models and maps of the terrain. 4. Surveillance payloads. Surveillance payloads are used for security and law enforcement purposes. They include high-resolution cameras, thermal imaging cameras, and even facial recognition software. Surveillance drones can be used to monitor borders, public events, and even traffic. 5. Agricultural payloads. Agricultural payloads are used for precision farming applications to improve crop yields and reduce costs. They include sensors that can measure soil moisture, temperature, and nutrient levels. Agricultural drones can also be used for crop spraying, pest control, and even planting. One area where WAVs are making an impact is in disaster management. WAVs equipped with sensors and payloads can provide critical support during natural disasters such as hurricanes, tornadoes, and earthquakes. They can be used to assess damage, map affected areas, and deliver emergency supplies to people in need. In the military, WAVs have become an integral part of modern warfare. They are used for reconnaissance, surveillance, and target acquisition. WAVs equipped with advanced sensors and payloads can provide commanders with real-time intelligence on enemy positions and movements. However, the use of WAVs has also raised concerns over privacy and safety. The ability of WAVs to monitor and collect data has raised questions about who has access to that data and how it is being used. There is also the risk of WAVs colliding with other aircraft or crashing and causing damage on the ground. As the use of WAVs continues to grow, there is a need for regulations and guidelines to ensure their safe and responsible use. Governments, industries, and UAV manufacturers need to work together to develop standards for their operation and use. This includes guidelines for data collection and privacy, as well as regulations for airspace use and safety. The use of WAVs has already shown significant impact on various sectors, and its potential to transform industries is enormous. For instance, in the agriculture sector, WAVs equipped with sensors and payloads can help reduce the use of pesticides and fertilizers, thereby contributing to sustainable farming practices. By using real-time data on soil moisture and nutrient levels, farmers can optimize their crop yield and minimize waste. In the construction industry, WAVs equipped with high-resolution cameras and LiDAR sensors can help create accurate 3D models of building sites, thereby minimizing human error and increasing safety. These models can also be used for project management, facilitating communication and reducing delays. Moreover, in the energy sector, WAVs can help to inspect and monitor oil rigs, wind turbines, and power lines, identifying defects and malfunctions promptly. This way, they can reduce maintenance costs and enhance safety for workers. In the transportation sector, WAVs can assist with logistics and delivery, enabling faster and more efficient transportation of goods and services. With advances in technology such as artificial intelligence and automation, WAVs could even deliver products directly to customers without human intervention. Finally, in the healthcare sector, WAVs can help to deliver essential medical equipment and supplies to remote or inaccessible regions. This way, they can improve access to healthcare services and health outcomes in underserved communities. However, the potential uses of WAVs are not limited to these sectors alone. The technology can be utilized in various other areas, such as search and rescue, wildlife monitoring, and scientific research. RCH. As UAV technology continues to develop and mature, we can expect to see new and exciting uses and applications emerge. From precision agriculture to disaster relief and infrastructure inspection, the potential of WAVs to improve efficiency and productivity is enormous. The continued use and adoption of WAVs will also lead to new job opportunities and skills development. The demand for UAV pilots, operators, and maintenance technicians is expected to grow significantly in the coming years. As a result, there will be a need for training and education programs to support the development of these skills. In addition, the use of WAVs will also create opportunities for innovation and entrepreneurship. New sensor and payload technologies, as well as software and data analytics tools, will drive innovation on and create new markets for services and products. However, there are also challenges and risks associated with the use of WAVs. Privacy concerns, safety risks, and regulatory issues need to be carefully considered and addressed to ensure the responsible use of this technology. By promoting responsible use and regulations, WAVs can continue to make significant contributions to industries and society as a whole. The future of WAVs looks bright, and we can expect to see